Your laptop is terrible at running modern AI, but a gaming console from 2020 can do it easily. That's not a coincidence. It's the difference between how a CPU and GPU actually work, and it's going to explain why every AI company on Earth is fighting over the same chips. Here's the simple difference. A CPU is built to do one thing incredibly fast. Think of it like a really smart cashier who can handle any problem but works one customer at a time. A GPU is built to do thousands of the exact same thing at the same time, even if each one is just a little bit slower. Think of it like a factory assembly line where 1,000 workers all do the exact same task on different items in parallel. That's the entire difference, and that's why AI needs GPUs. Before we dive into how that works, let's destroy 4 myths that are probably wrong in your head right now. Myth 1. GPUs are just graphics cards. Not exactly. A graphics card was invented to draw pixels on your screen. Drawing pixels is a weird problem. You have millions of them. For each one, you need to do the exact same math. Same lighting calculation, same shadow calculation, same color mixing. Over and over. A normal computer can't keep up. So, NVIDIA said, what if we build a chip that's amazing at doing the same operation on thousands of things at once? That's what a GPU is. Then 20 years later, someone realized, training an AI model is the exact same problem. You have millions of weights inside the model. You need to do the same math on all of them at the same time. That's why the graphics card in your gaming console became the tool that powers ChatGPT. Myth 2. CPUs are slower. Not slower. Just different. A CPU is like a really good chef. You give the chef any recipe, and they'll cook it perfectly very fast, but they cook one dish at a time. A GPU is like a factory with 1,000 cooks, but they can only cook the same dish. You give them one recipe, and all 1,000 start cooking the same thing on different ingredients at the same time. If you need one perfect dish, the chef wins. If you need 1,000 identical dishes, the factory wins. The GPU isn't faster at individual tasks. It's faster at repetitive tasks. Myth 3. You need a GPU for everything. Absolutely wrong. If you're writing documents, browsing the web, or editing spreadsheets, a GPU would sit there doing nothing. These tasks are all one at a time work. You click something, you get a response. You click something else. A computer built to do 1,000 things at once would be overkill. CPUs run your laptop because your laptop does one at a time work. Myth 4. Gaming needs GPUs for the same reason AI does. Close, but not quite. Games use GPUs to draw pixels really fast. That's pure repetition. Draw this pixel, draw that pixel, shade them all the same way. AI training uses GPUs to do math really fast. That's also pure repetition. Multiply these numbers, multiply those numbers, do it 1,000,000 times. They both need the same tool, the ability to repeat work fast. Here's the twist though. Modern GPUs aren't really graphics cards anymore. They're factories built to repeat work. Gaming is just one customer for that factory. AI became the bigger customer. Now let's talk about the mechanism. A CPU is like a really good chef. You give them an order, they read it, prepare it, plate it perfectly. Then they take the next order. One dish at a time. They're incredibly flexible and smart. But there's only one of them. A GPU is like a factory assembly line. You have 1,000 workers. You tell them all to do the same job. Worker 1 folds box 1. Worker 2 folds box 2. Worker 3 folds box 3. All at the same time. Each worker is simpler than your amazing chef. They can only do one thing, but they do 1,000 of them simultaneously. A CPU has maybe 8 or 16 cores, like 8 or 16 skilled workers. They're flexible, but there aren't many of them. A GPU has thousands of tiny cores. They're all doing the same thing. They can't be flexible. But there are so many of them working at once that flexibility doesn't matter. This explains everything. Why can a gaming console run ChatGPT but your laptop struggles? ChatGPT needs to multiply giant lists of numbers. That's pure repetition. A GPU crushes it. A CPU does it in batches and takes forever. Why does training an AI take months on a GPU but would take years on a CPU? Because you're repeating the same math operation billions of times. Each time the model learns, it does the same calculation across millions of numbers. A GPU can do millions of calculations at once. A CPU does them one by one. Here's the historical proof. In 2012, a researcher named Geoffrey Hinton taught a computer to recognize images. He used a graphics card from NVIDIA, a GPU. Before that, people were trying to teach computers using regular processors. It was painfully slow. One model took months to train. With a GPU, that same model trained in weeks. That's 10 to 100 times faster. That moment changed everything. After 2012, every major AI breakthrough used GPUs. AlexNet used a GPU. ImageNet used GPUs. The models that became Siri, Google Translate, ChatGPT, and Claude were all trained on GPUs. Not because GPUs are magic, but because repeating the same calculation a billion times is literally what GPUs were born to do. Gaming history is the reason this even happened. Back in the early 2000s, gaming exploded. Games needed to draw millions of polygons on your screen, apply textures, calculate lighting, all in real time. A regular processor couldn't keep up. NVIDIA realized rendering pixels is embarrassingly repetitive. Calculate lighting for Pixel 1, Pixel 2, Pixel 3. It's the same math over and over, so they built the GeForce graphics card. Thousands of tiny workers all doing the same job simultaneously. Then in 2012, machine learning discovered the same tool. And NVIDIA went from being a graphics company to being the most important company in AI. The advanced layer, why this matters for scale. Training GPT-3 on a regular CPU would take approximately 200 years on a single machine. On GPU clusters with thousands of GPUs, it took about 3 months. Not 10 times faster, not even 50 times faster. Literally 100 times faster. That's the difference between this is impossible and we can actually build this. Think about the math. GPT-3 has 175 billion numbers inside it. You need to train it on billions of examples. Each training step means multiplying giant lists of numbers. If a regular processor does one multiplication per nanosecond, and you need trillions of multiplications, you're talking centuries just for one training run. Do that hundreds of thousands of times and you're looking at 200 years. But a GPU with thousands of cores multiplies thousands of numbers at once. Same math, but 1,000 times in parallel. So the same 200-year problem becomes 3 months. That's why scale AI exists. Without GPUs, modern AI would be impossible. Think about what that means. Every AI company on Earth needs the same tool. OpenAI needs thousands of these chips. Google needs them. Meta needs them. Microsoft needs them. Everyone's competing for the same GPUs. NVIDIA controls the supply. The shortage of GPUs determines who can build AI and who can't. That's why NVIDIA became worth more than most countries. If you've made it this far, you understand the mechanism. And if you want to understand more mechanisms like this, hit subscribe. Like this video if the CPU versus GPU difference clicked for you. And comment what mechanism you want us to crack next. The more votes on a mechanism, the sooner we make the video. That's how we decide what to explain. So here's the thing about CPUs and GPUs that most people get wrong. A CPU doesn't fail at AI because it's slow. It fails at AI because it can't do thousands of things at once. A CPU is great at one complicated thing very fast. A GPU is great at one simple thing billions of times. They're designed for opposite worlds. The real problem isn't speed, it's parallelization. That's doing many things at the same time. CPUs can't do that. GPUs can. That's why your gaming console can run modern AI, but your laptop struggles. The console has a GPU. Your laptop probably doesn't. That's literally the whole story. What does this actually mean for you? If you're building anything with AI, you're not running it on your laptop if you want it fast. Your MacBook can run small models if you're patient. But for serious work, you're renting GPU time in the cloud. That's why everyone uses AWS or Google Cloud. Not because your laptop isn't smart, but because it doesn't have thousands of workers doing the same job at once. The takeaway: a CPU is a generalist. It can do anything, but one at a time. A GPU is a specialist. It can only do one thing, but it does thousands simultaneously. AI is one thing repeated billions of times. That's why we use GPUs. Gaming made them affordable. AI made them essential. And now every company trying to build AI is fighting over access to the same chips. So which mechanism do you want cracked next? The more specific you are in the comments, the higher the chance we make it. How does encryption work? What is load balancing? How do banks actually create money? How do dark pools work? Drop it in the comments. Let's crack another one. See you next week for our next episode.